These notes are for AP Calculus AB. This is Objective 6.9, on which we'll be talking about approximating area under a curve with trapezoids. We've already covered rectangles, and we'll be coming back to doing rectangles more. But we're gonna look at trapezoids first, and you'll notice with my curve drawn over here on the side that the trapezoids fill in the space a lot better than just rectangles do. Rectangles typically have a lot of unused space or too much space used. And in drawing trapezoids, we follow along the shape of the curve a lot better than with a rectangle. So typically, we're used to seeing a trapezoid this way, lying on its side, where the bases are at the top and the bottom. You have your height here between the two right angles. This is what we're working with, only they're all standing up. So I can see my parallel sides are the heights, but they're actually the bases of the trapezoids, and the heights go across the bottom. And I think that's the first thing you want to do in thinking of trapezoids from rectangles. With rectangles, we usually have the width or the base at the bottom and the height going up. But we want to switch our thinking there with trapezoids. We want the height to be the bottoms and the bases going up. All right. So really all you need to know is the area formula for a trapezoid. And just like with rectangles, you calculate each one, you add them up, and you have your approximation. So remember, if I had a rectangle or a square, or I'd just be doing area as base times height. When it comes to trapezoids, there are two bases. So instead of base times height, it's average base times height. You average the two bases and then multiply by the height to get the area. In this case, you want to remember that the height is the change in x, which is given by b minus a over n. And that's something that we covered early on in the unit, but that was before break. So I just added that in here to remind you of what that formula was. So what we're going to do to start with is write out the formula for area under a curve. We're going to use this picture here to write that out. And it's important to note that they are equally spaced trapezoids. So they're equally spaced apart. Anytime you have trapezoids or rectangles that are unequally spaced, there's no formula. You find the area of each one individually and add them up. And that's really all you ever need to remember. So the formula is really not necessary, but we're going to write it down anyway. And then I'll let you know, you can learn it, you can know it, although it's pretty simple. So you can remember it and use it, but you really don't need to. So we'll start with the area of the first trapezoid. So we want to average our bases and multiply by the height. So my bases, these parallel sides, their lengths are f of a and f of b. So remember, the bases are just like the heights of the rectangles, f of a and f of b. So we have f of a, sorry, not f of b, f of x1. Average the bases, multiply by the height, which we're going to write as delta x. So that's the area of our first trapezoid. All right, so we're going to add that to the area of the second one. So again, average the bases, f of x1, f of x2. Average, multiply by the height. Okay, and we repeat with the next one. F of x2 plus f of x3. Average the bases, multiply by the height. And last, f of x3 and f of b. Average the bases, multiply by the height. And so if you're developing a formula, the next thing you do is look for what they all have in common. They all have a delta x divided by 2, which means we could factor that out. So my area approximation I take my delta x divided by 2. And when I factor it out, I'm left with f of a plus f of x1 plus f of x1 plus f of x2 plus f of x2 plus f of x3 plus f of x3 plus f of b. Now, you probably noticed that some of those repeat. There are 2 f of x1s, 2 f of x2s, 2 f of x3s, but only 1 f of a and 1 f of b. And that's because the first and last trapezoids only use a and b one time. All the others, they're sharing sides. So the first and second trapezoid share f of x1. F of x2 is shared and f of x3 is shared. And so there's 2 of all the values in the middle, 1 of the first and last. So although we have 4 trapezoids, and when we do rectangles and we factor out that common width, we're left with the heights of the 4 rectangles. But with trapezoids, you're going to end up with 5 values inside. So 1 more than the number of trapezoids, that is. So delta x over 2. Here you have f of a plus 2 f of x1, 2 f of x2, 2 f of x3, and f of b. And that really doesn't look like it's simplified a whole lot, but that is called the trapezoid rule. So if you ever see that mentioned, it's just talking about this specific formula. And, you know, this goes on and on depending on how many you have. So this could be adding 2 f of x sub n for as many as you need until you get to the last one. Okay. So again, it's not something that you have to memorize, and that's because, you know, even if you are given equally spaced trapezoids, as long as you know the area of each one, we can just calculate it that way. So I recommend, it's nice to know it, but I'm going to show you every problem. We're just going to go through and do the area of each one and add them all up. Okay. So again, it'll be up to you if you want to choose to do that differently. In our example here, we're going to use the function x squared plus 1 on the interval 1, 5 with 4 equally spaced trapezoids. All right, so 2 parts to this problem here. First, we want to approximate the area. Approximate the area. So that is under the curve on the interval 1, 5 with 4 equally spaced trapezoids, or of equal widths or heights, that is. So a picture can help, although really the only thing that we ever need to look at is the x values. So it's really not going to matter how perfect your graph looks. So we have, because it's from 1 to 5, and this is x squared plus 1, so I'm not going to draw it to scale or anything. I'm just going to exaggerate it so I can give you 1, 2, 3, 4, and 5. And we want to equally space them from 1 to 5, so that's every unit, because we want 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So that'll be my 4 trapezoids. So your heights, which are actually the bases for the trapezoids, are all parallel to one another. You have right angles here at the bottom. And then just like last time, we can see here's my first trapezoid from 1 to 2. The second trapezoid from 2 to 3. Three to 4. And then 4 to 5. And you can see just how nicely the trapezoids follow the slope of the curve. So I can see the 4 equally spaced, so it's 1 unit. And if you really wanted to figure that out by hand without just looking at the picture, that equally spaced is that common width. So it's that B minus A divided by the number, and that's how you get 4 over 4 is 1. So each one is 1 unit width, or in this case, the common height or spacing between them. So again, I'm not going to use the rule to figure this out. I'm just going to write it out like I did the first time way back here and write out the area of each one. And then, you know, if I see something in common, I could do a little factoring and simplify. If you want to use the rule, you can use the rule. So we'll start with this area approximation. So for the first one, to average the bases, we do f of 1 and f of 2. And then times the height. And the height is just going to be 1 for each one. That's what we just figured out here. So I can write multiply by 1 just to remind you of it. And then we'll go on to the next one. So the second one, f of 2, f of 3. We want to average that and multiply by 1. So we do the third one. So we have f of 3, f of 4. Average, multiply by 1. And the last one, f of 4, f of 5. Average, multiply by 1. So remember that 1 is just that delta x, that common width or the spacing of them. So from there, notice they all have a 1/2. So I almost just, anytime they're equally spaced, you're kind of just developing that formula, the trapezoid rule, over and over. So even if you forget it, you're just going to go through the process anyway. Take out the 1/2. You're left with f of 1. You're left with 2 f of 2s, 2 f of 3s, 2 f of 4s, and f of 5. And that right there is the trapezoid rule anyway, and I just went through it a little faster. From there, you can use your calculator or plug them in by hand. Pretty easy to plug in by hand. So 1 squared plus 1 is 2. Plugging in 2, we get 5. Plugging in 3, we get 10. Plug in 4 to get 17. Plug in 5 to get 26. And so we just keep working on this. So 92. And then half of 92 is going to give us 46. And that is our approximate area with trapezoids. All right, so the last part is you might be asked to do some rectangle approximations left and right hand, so you'll want to review those notes that we did back at the beginning in 6.1. And so the only other thing I'm going to ask you for here is the actual area. And so since my curve is non-negative on the interval 1 to 5, then I can find the area by integrating my function from 1 to 5. So we'll go ahead and integrate. We get x cubed over 3 plus x. Evaluate from 1 to 5. So we have 5 cubed, 125 over 3 plus 5. And then we'll subtract and plug in 1. So we want to be careful here. That subtraction sign is going to affect both things when I plug in 1. So I've got 1/3 plus 1 inside. So 125 thirds minus 1/3 is 124 thirds. And then 5 minus 1 is 4. So to add this together, we'll rewrite 4 as 12 thirds, which will get a sum of 136 over 3. So to compare that to my approximation, in your calculator, you get this to come out to 45 1/3. And so you can see just how close that actually is. This is our exact answer, but yeah, 45 1/3 is fine. And that is it for 6.9. So that's the end of our notes for today.